You're welcome to solve this nice exponential equation, which is 4 to the power x plus 2. This is equal to 30. What is the value of x? Now, solution. We have that 4 to the power x plus 2. This is in the form of a raised to the power n plus m, which we can express as a to the power n times a to the power m. Applying this exponent property, so here we have 4 to the power x times 4 to the power 2. This is equal to 30. So this is 4 to the power x times 4 to the power 2, this is 16. Then this is equal to 30. So let's divide both sides by 16. Here by 16. So that's 4 to the power x. This is equal to, now we can simplify here. By 2, this is 15. By 2, this is 8. So we have 4 to the power x is equal to 15 over 8. To solve for x, we introduce logarithm on both sides. So this is log 4 to the power x. This is equal to log 15 over 8. Now, log 4 to the power x, this is in the form of log 4 to the power x. This is in the form of log a to the power n, which we can express as n log a. Applying this exponent property, then log 4 to the power x, this is the same thing as x log 4. This is equal to log 15 divided by 8. So dividing both sides by log 4, then this is equal to, that is x is equal to log 15 divided by 8, dividing this by log 4. So log 15 over 8, this is in the form of log a over b, which we can express as log a subtract log b. Applying this logarithm property, then we can express x as log 15 divided by log 4 subtract log 8. We have log 8 here divided by log 4. So we can express 15 as 5 times 3. And we can express, we have x is equal to log 15 over 8 divided by log 4. So log 15 over 8, this is in the form of log a over b, which we can express as log a subtract log b. Applying this logarithm property, then we can express x equal to log 15 divided by log 4. Then subtract log 8 divided by log 4. We can express 15 as 5 times 3. We can express 8 as 2 to the power 3. And we can express 4 as 2 to the power 2. So substituting this, we'll have x equal to log 5 times 3 divided by log 4, which is log 2 to the power 2, then minus log 8, which is log 2 to the power 3, divided by log 2 to the power 2. The next step is that log 5 times 3, this is in the form of log a times b, which we can express as log a plus log b. Applying this logarithm property, then we have that x is equal to log 5 divided by log 2 to the power 2, then plus log 3 divided by log 2 to the power 2, then subtract log 2 to the power 3 divided by log 2 to the power 2. Now, From here, applying the power rule property, we can express x equal to, this is log 5 divided by log, that is 2 log 2, then plus log 3 divided by 2 log 2, and then subtract 3 log 2 divided by 2 log 2. Let's simplify here, log 2 and log 2, so that now we have x equal to, now this is the same thing as half log 5 divided by log 2, then plus half log 3 divided by log 2, then subtract 3 over 2. The next step is that log 5 over log 2, log 3 over log 2, this is in the form of log a divided by log b, which we can express as log a to base b. Applying this logarithm property, then we can express x equal to, now this is half log 5 to base 2 plus half log 3 to base 2, then subtract 3 over 2. But you can note here that a half is common, so we can factor out a half. So we have a half into the parentheses log 5 to base 2, then plus log 3 to base 2, subtract 3, close the bracket. So this is the value of x. This is the value of x. Let's verify that this value of x satisfies the equation by following these steps. Let's verify that this value of x satisfies the equation. Now, if you recall, we entered 4 to power x plus 2. This is supposed to give us a value of 30. Let's substitute the value of x. So we have 4 to power a half into the parentheses. This is log 5 to base 2 plus log 3 to base 2, subtract 3, close the bracket here, then plus 2. This should give us a value of 30. Now the next step is that we can express 4 as 2 to power 2. Substituting this, we'll have 2 to power 2 times x, which is, this is half into the parentheses log 5 to base 2, then plus log 3 to base 2, subtract 3, close the bracket, then plus 2. This should give us a value of 30. The next step is that we can simplify here, so that now we have 2 to power log 5 to base 2 plus, here we'll have log 3 to base 2, subtract 3, plus, now here we have 2 times 2, this is 4. Then this should give us a value of 30. Now here we have 2 to power log 5 to base 2 plus log 3 to base 2. Now minus 3 plus 4, this is plus 1. This should give us a value of 30. The next step is that 2 to power log 5 to base 2 plus log 3 to base 2 plus 1. This is in the form of a to power n plus m, which we can express as a to power n times a to power m. Applying this exponent property, then we have 2 to power log 5 to base 2 multiplied by 2 to power log 3 to base 2 multiplied by 2 to power 1. This should give us a value of 30. Now, we have 2 to power log 5 to base 2 and 2 to power log 3 to base 2. This is in the form of m to power log a to base m, and this essentially is supposed to give us a value of a. Applying this logarithm property, then 2 to power log 5 to base 2, this will give us a value of 5, and 2 to power log 3 to base 2, this will give us a value of 3. Let's substitute these two values here. So we'll have 2 to power of 5 to base 2, which is 5, times 2 to power of 3 to base 2, which is 3, then times these two here. So that's times 2. This should give us a value of 30. 5 times 3 is 15, times 2, which is 30, and this is equal to 30. So the left add side is equal to the right add side. And this implies that the value of x, which is a half into the parentheses, log 5 to base 2 plus log 3 to base 2 minus 3, actually satisfies the equation. So kindly follow the steps, like this video, and subscribe. See you in the next video.